Good morning, ladies and gentlemen, and you're all very welcome to webinar number 30 in the Irish Bioenergy Association webinar series. This morning, our topic is MyGug, microscale anaerobic digestion, a food waste solution providing renewable energy gas to small business and households. And we're delighted that you can join us this morning for our webinar. My name is Sean Fine, I'm the CEO of the Irish Bioenergy Association, and we look forward to presenting to you this morning. Just before we begin, a few very brief introductions to our organisation. So we were established in 1999. We're the representative body for the Irish bioenergy industry in the island of Ireland. We cover many sectors across biomass, biogas, biofuels, biochar, wood fuels and energy crops. Our role is to lobby, advocate and develop the sector, work with our members and external stakeholders to improve knowledge and encourage activity within the sector. We have a broad and diverse membership and open to discussing membership with anyone that's on our webinar this morning that would like to become a member of the organisation. And we roll out a number of research and development projects as well as the wood fuel quality assurance scheme. This is webinar number 30 in our series, so a wide diverse range of topics covered to date. So just a reminder here to any members or stakeholders present on our webinar this morning that would like to present as part of our webinar series. If you could get in touch with myself or my colleague Teresa O'Brien, we'll be happy to discuss further with you. This morning's webinar, we're hearing from Kieran Coffey. Kieran is the Chief Technical Officer with MyGug Limited. And we'll also hear from Noel Gavigan, my colleague, who is the RBA Technical Executive. There is an opportunity for you to ask your questions. We encourage you to use the Q&A tab at the bottom of the screen, and we'll endeavour to answer as many questions as possible. So just to take the opportunity to introduce our next webinar, a slight change in our format in that we moved to a Tuesday from the Wednesday because of the SEI Energy Show taking place on the 30th and 31st of March. So Tuesday the 29th of March is our next webinar, and we will be launching at that webinar our wood fuel quality assurance scheme animation video, and we will be talking about the topic of sustainability from a wood fuels perspective and sustainable forest management as part of that webinar. Full details will be published through our social media channels in the coming days. We encourage you to register for that webinar and participate in that. So to introduce this morning, introduce our speaker. So Kieran is a mechanical engineer, has been involved in the design and the of wastewater and wastewater treatment plants for over 25 years. And most recently, Kieran and his team has been involved in the design of a microscale anaerobic digestion solution. So Kieran will present his innovative solution here, which addresses the issue of food waste, giving you renewable energy for your cooking, but also it's a food waste treatment system that will integrate into a household, but also into a business. It's a fossil-free solution to disposing of food waste, and it does turn food waste into renewable energy, and also a biofertilizer, which can be used in your garden to grow your vegetables and your plants. So this morning, while we focus in a lot of our webinars on the medium to large scale and also the small scale, we're speaking about a different scale of anaerobic digestion today in terms of microscale, and it just shows you the versatility of the technology to address challenges at all levels. So I'm going to stop sharing, Kieran, and I'd invite you to begin. And thanks very much for taking the time out to participate this morning, Kieran. So over to you.
Thanks everybody for joining us this morning, and I'm delighted to present our microscale anaerobic technology to you here this morning. And the first question I want to answer is why Microad? Why would you choose Microad? And to understand, firstly, about food waste, you need to know where it comes from. And there was a very interesting report done in the European Union a number of years ago, and it showed where all the food waste emanates from. And interestingly enough, and interesting for us on our micro scale, most of the food waste comes from households, 53%, and 12% comes from food service. So 65% of all food waste comes from small settings like this. And this represents 88 million tons of food waste, this chart. So, and households represent 47 million tons of the total. So providing a micro scale solution will create a micro circular economy. So it'll enable our customers to create their own micro circular economy. And it's a full solution to food waste, as I'll explain in a while. So it will minimize and get rid of your transport requirements. And the beauty of anaerobic digestion is that you capture the value of the energy that's in your food, and you can use it locally in the form of biogas. You also harness the organic and the nutrient value in your food, and you can reuse it locally. And there's a big issue with soil health in the world. This will improve your soil health, and it'll sequester carbon. And one key issue for us is that when you treat locally, you will not get contamination of plastics and other wastes, deeming them useless as well as the food waste. So this is a very important point as well. And with all of these, the above, everything will reduce fossil fuel, your own fossil fuel dependence. So anaerobic digestion versus composting. What is the difference between these? On the top right-hand corner, we have our domestic micro-scale anaerobic digester, the MyGug. And at the bottom, we have a standard composter that we were all familiar with. Now, as I said before, the big difference is that you get a gas from your digester that you can use locally to cook. And a domestic digester can give you up to 80–90% of your cooking gas requirement. And instead of a solid compost waste that you get from a composter, you get a liquid fertilizer that you can pour directly on your plants and vegetables. Now, also one huge difference between the two is that MyGug is a full solution for food waste. It'll take cooked, uncooked meats, it'll take liquid waste, whereas the composter is only a partial solution to food waste. This chart here is from a UN report that was done a number of years ago on food wastage footprint. And the big items here, the food groups that are creating the biggest problem in the world are meat, milk, and grains. And you can see the requirement for water for meat, milk, and grains, and the biodiversity and ecosystem cost associated with these foods. And one of the things that MyGug will do very well is take these types of foods and digest them and convert them into heat and energy in the form of the biogas and then a nutrient. Now, when we think of food waste, we don't normally think of liquids as a food waste, but it in fact is. And you can harness, you can get the energy from that milk and use it locally. So just to summarize, a Microad will accept all types of food waste. You don't need an additional carbon source for it to work properly. It'll create an energy source in the form of biogas. It's fully enclosed, so this is key. It won't attract rats or vermin or flies, and it'll provide a constant supply of fertilizer. And like I said, you can use, you can put in all sorts of liquid waste, soups, yogurts, milk, whatever. Now, the food waste industry is highly dependent on transport, and we want to break that link with transport. And to look at this, we want to look at another industry from the past, and that was the ice and cooling industry. So back in the 1800s, it was common to harvest ice from the large lakes in Northern America and Norway and transport that ice worldwide. And it was used in these types of cooler boxes to keep food cold. The industry then developed in the mid 1800s, and there was an industrial ice making was invented. So there was less requirement for transport then, and these large ice factories were introduced. But there was a major change happened with the introduction of the fridge in the 1920s. And over the next 40 years, the dependence on transport to transport ice around the world was completely eliminated with the invention of the fridge. And this is the timeline. And so basically in the 1920s, the fridge was introduced, and that completely changed that industry. If we look at this chart here, in the mid-20s, nobody had any fridges, and then between 1930 and 1960 went from practically 0% up to close to 100% of people using fridges. So this is an example of where a micro technology completely changed an industry. And we want to do the same with food waste. We want to provide a solution, an immediate solution to people to get rid of the really difficult to treat food wastes on their own properties. Now, how do we provide a reliable system? I want to look first at the system in China. China has probably the most developed industry, anaerobic digestion industry of all, and they're reported to be up to 30 million small-scale anaerobic digesters in China. And a lot of them look like this. They're a dome-style digester. They're similar enough to a septic tank. And if you imagine there's reported to be 450,000 septic tanks in Ireland, it does make sense then that there's 30 million of these units in China. So these units provide local micro circular economies in rural areas and all over China, where people can get rid of all of their organic waste, their food waste, their animal manures, etc., and then use the gas locally. Now, all of them are quite large, and they wouldn't suit Europe or the US. So to allow a system like that to work in Europe, it had to be miniaturized. And we've miniaturized it by insulating a tank similar to the fridge, where you had basically an insulated container. We've insulated our digesters. We've provided heating, and we've also provided a huge amount of technology where we monitor the level in balance tank. Once the food waste is macerated, it goes into this balance tank, and we dose the food waste from this balance tank into our digesters. We monitor and maintain the temperature in our digesters at ideal temperatures, mesophilic temperatures. And then we monitor the whole process. So we can monitor remotely, and we can help our customers if they have any problems. And we are basically harnessing the power of the Internet of Things with our technology. So I'll just show you a video of the unit, if it'll expand for me. So I'll start that again. So this is our domestic digester, where you take off the lid and you dispose of your food waste in and macerate it. It goes into a balance tank. The gas comes out the end of the unit, goes through a moisture trap, and then it goes through a bubbler and a filter. And the egg is obviously where the digester is and all the digestion takes place. And then there's a hose at the very left here. You can see where the liquid fertilizer comes out, and you're able to harness that. We provide a range of digesters, not just domestic digesters. The domestic digester will treat about half a ton of food waste per year, but we have solutions to up to about 15 tons of food waste per year. As you can see here, the arrangement is slightly different with a kiosk and a sink and a larger egg outside, but the concept and the functioning of it is the exact same. We'll get past this, sorry. So some of the normal questions that we get asked are, is it safe? How much food waste will it accept? How much gas will it produce? And will it heat my house? And why is it egg-shaped? Now the unit, the gas is fed into a biogas bag, and the biogas bag is at atmospheric pressure, so there's no danger of that gas leaking into your house. Like when you have a gas cylinder, it's under enormous pressure. So if you have a leak in your house, it will release the pressure in the cylinder will force the gas into your house. That will not happen with a domestic scale anaerobic digester. Our domestic digester will treat 1.5 kilograms of food waste per day, about just over half a ton of food waste per year, and it will produce 3 liters of liquid fertilizer that you can use. The unit itself, the other questions we ask, will it heat our house? We are really focused on using the gas to replace common cylinders, so we're focused on using it for cooking. It's egg-shaped because the egg is ideal for mixing, and mixing is very important in anaerobic digestion. Now, I'd like to show you a video here of the real benefit, and this really highlights the micro circular economy nature of our technology. The digestate that comes from our MyGug is used. It was used in here in this polytunnel, and it was used to grow all of this food locally. And again, the micro circular economy is you remove transport, you remove your dependence on outside sources, and you use what you have to create food locally, and you don't have to use, you know, fossil fuel fertilizers, and the health of your soil is really, really good, and it will produce tomatoes like this, vegetables that you just go and pick that are 20 minutes from your door. You bring them in and you cook them. This is what our micro circular economy is all about, and the tomatoes and all of the vegetables that we produced here served us for 3-4 months when we put them into the freezer to store them, and we were able to use them well into the winter time. So this really sums up what we are trying to achieve with micro circular economy, giving people a full solution for all the different types of food waste that they produce in the home. And we've been working very closely with the fabricator, and we're going to be sending the blue unit over to the UK in the next couple of weeks. And the green egg on the left is our domestic digester. That's the size of the domestic digester. So I'd be delighted to take any questions that anybody may have. And thanks, Sean and Irbia, for inviting me to talk today. Thank you.
Okay, thanks very much, Kieran, for your interesting presentation. And this is certainly a new adventure from the point of view of our own engagement at this level and scale. So if I could also ask Noel to turn on your camera. And we have some questions coming in, and we will address those questions in a couple of minutes. So keep on sending forward your questions. If I could just maybe to give you a chance, Kieran, to catch your breath for a second after your presentation, maybe bring in Noel. I think if you could maybe outline, Noel, your own experience or understanding from a point of view of micro scale and maybe even micro stroke small scale. You would, in our presentations on our small biogas demonstration program, have very clearly articulated the volume of small digesters that are across the world. And Kieran has highlighted China as being an example, but obviously India as well. So do you want to just broadly elaborate on your own experiences from that perspective in terms of what you know from about that scale?
We've used the very same example, the fact that, you know, across much of Asia, there's a proliferation of small digesters that are very much almost septic tank based, where you've got small homesteads, possibly with, you know, obviously family, possibly a small number of animals as well, 1 or 2 tied up cows or pigs, where you've got a lot of material that can actually feed into this system. So what that demonstrates, and Kieran has outlined there, is that a biogas, it doesn't necessarily need to be a huge industrial scale plant. We do need those for our brown bin waste collections, but on a domestic scale or on a much smaller scale, we can look at different types of units. You know, the bacteria obviously don't need a large unit. They're obviously very small themselves. So once they have the right conditions, they'll be able to work. They'll be able to feed off what we give them. So, I mean, using that example, you know, we've used literally that diagram ourselves. That's what we term ourselves the Chinese model. There's often called the Indian model, which is slightly different, where you have a floating roof for the gas storage as well. But ultimately, it just demonstrates, and what Kieran is doing there with the MyGug is demonstrating that small scale technology is very viable.
Micro scale, I think, Noel, as well. Yeah.
Mm.
Yeah. Okay, thanks very much, Noel. The questions are flying in here, so we may start, Kieran, to go through them. So we'll take them as they come. So,
yeah.
Does the feedstock need to be processed? Will items like bones cause issues? So that's Brian asked that question.
Yeah, it'll take chicken bones, a macerator, anything that will go through a macerator, really. So what we say is you can put a chicken carcass through a macerator, no problem. But harder bones like beef bones and things like mango stones and avocado stones, we still use composter ourselves. So it's you know, so items like that. Other things like say the head of a pineapple, you know, real woody type of material.
Yes.
Those types, they aren't really suitable for our digester, but but 99% of all other foods and liquids can go into it.
And just explain the maceration process. Where is that on your system? Is that your sink? Is it, or does it feed directly?
No, the unit itself is outside. So you can see here that there's a cabinet next to the egg. So the macerator is in the sink, and you've got a button here that you just press and turn on the tap, and it macerates the food waste outside. So
okay.
So you're just you know, it's there outside. You just put your food waste in, and it's readily macerated.
Okay. Follow-on question from Brian, and again, if you can't answer some of these, we can get back to people after individually. Yeah. But Brian asks here, what are your business goals over the next few years? So
well, we'd like to go like the fridge went, and have that sort of trajectory. And look, the big thing for us is being environmentally friendly and providing a solution. You know, the solution's really India. It's suitable because of the warm climate, and you know, for a standard digester, we've had to design in the insulation and the control and everything for colder temperate climates. So we want to make that available to everybody.
Okay. Question from Enrico here. What type of maintenance does the device need? So how often is there maintenance required? How often does it need to be maintained?
There's very little maintenance. You could see on the video there's a moisture trap. You need to empty the moisture trap every so often. With the automated units, there's rubbers, seals that need to be changed every 3 years. But apart from that, there's very little to maintain in them.
Okay. A question from Siobhan, and thanks Siobhan for joining this morning. Siobhan says she uses 5 small cylinders of gas annually. Will it replace these?
It could replace, we reckon, about 80% of those. So,
80%.
And a lot of anaerobic digestion depends on the feedstock. So we say that anything that will make you fat will produce a lot of gas, like cakes and sugary things. And you know, carrots and broccoli won't produce much gas. So it depends on what sort of food waste you're putting in. Oils and greases obviously will create a lot of gas. And
just on that, you've focused obviously on food waste, but could you put in some clippings from your lawn and stuff, or is it no, it's just specifically a food waste solution?
Yeah.
Okay. Next question from Deirdre. Thanks, Deirdre, for joining as well. What sort of cost? And I think the cost question is featuring on a couple of the questions. So
the cost, the domestic.
On that?
Yeah, we've launched our domestic product, and the base unit isn't automated. It's got a manual pump, and that retails for 3,599. That includes 13.5% VAT. And then our larger digesters go up to about 30,000 euros. So, you know, look, what we say is the value isn't just in the gas, it's in creating this micro-circular economy. It's in creating the food you saw in that video. It's good for your mental health. You know, you go out and you're not reliant on you saw since yesterday 39% increase in gas prices.
Yeah,
you won't, you know, I think that people need to be more reliant, and our digesters help them with that.
Okay, so just to clarify, 3599 including VAT is your, okay, so that's thanks for confirming that. It is a sizable cost, I suppose, but
yeah, but if you compare to solar panels, Sean, you know, a solar panel system could cost you up to 14,000, and it will only give you a fraction of your electrical requirements, and in winter generally not at all. Whereas with a digester, it'll give you gas all year round. It will consume a slight bit more electricity in winter because of the temperature drop. It'll hardly consume any electricity in the summer, but it will give you that gas the whole year round.
Okay. Question from Kevin. You mentioned that you're 20 minutes from the house to harvest your veg. So obviously you're...
No, 20 meters, I should have said.
Oh, sorry.
So,
okay.
So that was it. So it's a walk. Okay. It's a 30-second walk away.
Okay, that's very good, and thanks for clarifying that. Michael, and thanks, Michael, for joining the webinar. Good to see you. Excellent, Kieran. What cost? So we've typical domestic scale. So we've covered that in terms of the cost. Enrico, again, another question. Do you do a feasibility analysis to understand what size is needed? Also, what for the type of bacteria? So, is that have you?
Well, generally, household, again, part of the European study said that each adult will produce about 92 kilograms of food waste. So we base our figures on that. And for restaurants, commercial outlets, they'd have to see how much food waste they're producing to understand what size of digester is required. So
okay, the next question is, can I ask you to mention the food waste and gas output quantities again, just to maybe the volume in, the volume in and the volume out, and the volume of digestate out as well?
So I can show you this chart here. So this is the domestic scale unit. So it's designed to take 1.5 kilograms of food waste. You get 3 liters of digestate out. That's equivalent to 550 kilograms of food waste per year. You'll get up to about 300 liters of biogas out per day. That will give you about 1 to 2 hours cooking. And that's equivalent to about 4 cylinders of yellow cylinders of compressed gas.
Okay. And Noel, if I could just bring you in to give Kieran just a second there. In terms of quantification of this biogas, obviously, probably separate to this, we've seen huge price in fossil gas prices, or huge increase in fossil gas prices over the last few weeks and months. Do you want to elaborate maybe on the broader economics of biogas, not specifically this example in terms of the micro scale, as a result of the price increase in fossil gas?
Yeah, look, I suppose everyone would have seen the price increase announced by one of the main suppliers yesterday of just under 40% for the domestic gas price. But I suppose behind that, we're seeing substantially larger increases on commercial gas costs, and the cost of putting gas onto the grid. So the commercial and the trading price, that, you know, similar to where we Brent crude will tell you where oil is, there is also trading prices for gas. That's gone literally up tenfold at one point. So now there's a little bit of panic in the market, and it is settling back down. But still, the wholesale price is far higher than domestics are paying at the moment. So the CRU is protecting the domestic market from it. But the prices of gas, by the looks of it, are going to stay quite high. And there's every place we can take gas from or take energy from is going to be more and more valuable as time goes on.
Okay.
So I think it's a very timely piece, this.
Okay. Question from Michael again, and Kieran, I think you may have covered this, but just, you mentioned that gas is most suitable for cooking. Can it be used with gas boilers? How do you clean this if it's required? So
no, our focus is on cooking. It's the simplest and best way to use it.
Okay, that's quite straightforward. Again, I think you've answered this one from Keith. Can you use green waste or as a feedstock? So you've answered that, I think, in that it's specifically for food waste. So that's that one covered. Another question from Deirdre. could this be scaled up for a community housing estate or group of farmers at a small local level, local scale?
Yeah, it's I suppose that what isn't available is something at this scale that's fully automated. The larger size is we can scale up, but our focus really is on the micro scale. And you know, again, going back to the fridge analogy, like, you know, there's small fridges and there's big fridges, but we just want to stay to our core. And maybe we might go up to 25 tons a year of food waste, and that probably will be as big as we'll go.
Okay. There's a question kind of following on here from our own colleague Porrick. He said, if there's something that is this something that hotels could use, and is it a case of using more than one unit if you have different kitchens on site? Or could you maybe explain to us how your unit can be scaled up from the point of view of smaller businesses above the domestic household, or is that part of your intention to
we visited a number of hotels, and when you have a hotel, it's sort of an industrial scale more so. You know, there's a lot of people buzzing around, and our system is something that, you know, you can't have plastic forks going into it or napkins and other things, you know, so it does need managing. And I think the larger you get, the more complicated it can become. So those larger hotels, at least a small hotel, no problem, and you know, things like golf courses and nursing homes. But once you start getting up to a larger scale, you know, you're probably better with a larger digester or a different system.
Okay. Question here just about the mechanics of getting the gas into the cooker. In terms of how does that work, and this person is asking, do you still need a gas bottle on standby? So maybe could you just elaborate on that?
Yeah, so the gas is stored in a gas bag like this, and we supply a 20-watt gas pump. So there's a line that comes from this bag into your kitchen, and you just turn on the gas pump and it feeds your hob. Now, in our own house here, we have been using biogas for the last 6 weeks, I'd say, and we might have to use the gas bottle for 2 or 3 days this week, and then we might, again, you know, it depends. And the beauty of a gas bag is you can see how much you've got left. With a gas cylinder you can't, but we say it can give you, in a household setting, up to 80-90% of your gas use, and that it'll depend on the food waste that you're putting into it. But if you want to have something in standby, yes, you would need a gas cylinder.
And I think it's a very important point, and Noel, if you could come in on this, about the various different feedstocks for biogas have different biogas yield potential. So Kieran has elaborated on that in terms of like sugary feedstocks have more biogas potential than, say, peelings from vegetables. So could you elaborate on that at a broader level, Noel, in terms of
look, I mean, that's standard across. Every material has a different gas value, and it really depends on the energy that's contained within it and how digestible it is. Generally, looking at an industrial scale, and people that are looking at putting crops in, usually they would say the more digestible it is for a cow, the more it'll work in a digester. So it's somewhat similar to this, and it's a very good analogy that Kieran made, that those foods that make you fat will also produce a lot of gas for the digester. Okay. So look, again, it's back to the sugars and greases that really make it work. You know, now you can't overload it with those. You know, there's a level that the bacteria, it's not healthy for them either if there's too much. But I mean, I don't think you'd overload it on a domestic level.
Okay, thanks, Noel. Question from Stephen: is the unit capable of taking the non-edible parts from your polytunnel, so the tomatoes and cucumber leaves and stems, if macerated, so that you wouldn't necessarily have?
Generally, we wouldn't put sort of the vegetation. You know, that's, again, it's
probably low yielding from a biogas potential anyway. So
yeah, it is. Yeah, any woody material is very hard to digest as well. So again, like I mentioned, they say pineapple tops, things like that aren't really suitable to it.
Question for Robert, and thanks for joining, Robert. Great presentation. And
Thanks, Robert.
Robert's question is the suitability of the MyGug for digestion with waste, animal waste, chicken litter, not farm scale, just domestically. So I assume Robert is talking about if you have your own chickens or your own farm animals, but it more not.
We have a domestic customer that we're delivering to soon, and they have rabbits, domestic rabbits, and they'll be putting their rabbit poo in there. So look, as long as it's not mixed in with stones or something like that, yes, chicken poo won't do
the quality makes a difference, and it obviously, like food, it can't be contaminated with inert material, I suppose, is the question.
Yeah, exactly. Yeah.
Stones and the like. Okay. Thanks, Robert. Next question, and keep your questions coming. I think we've never had as many questions in a webinar before. So, Kieran, you've certainly stimulated a lot of interest in this particular area in your technology. So,
great.
Next question: what kind of maintenance does the MyGug require? E.g., is there tank cleaning, monitoring? So, what's the maintenance requirements?
Yeah, I mentioned before about the moisture trap and just emptying the moisture trap. Also, you would remove some sludge, depending on how much you're using the unit, at least once a year. So you just take out a bucket of sludge, and that sludge is really good for using on vegetables as well. So. And then, like I say, every 3 years, if it's a fully automated unit, there's rubbers in the pumps that would have to be changed. Okay.
Next question is again about the cost, but I think we've covered that. And just you mentioned 3,599 including VAT, just to confirm. So that's the domestic unit. Question from Donal. Good to hear from you, Donal, too. What would an LPG or natural gas cooker need conversion? As I assume the gas from this would be of a lower CV value, so calorific value.
Yeah, the biogas is usually between about 55 and 65% methane. So you need more gas to operate in a standard gas hob. Generally, we use you can just increase the size of the jet, and there's a small other adaptation that you can make to make it suitable for a regular gas hob. But we supply a biogas stove with our units, and ultimately we want to see built-in units, but we provide a biogas stove.
Okay, and just a question on that. Do you need to do any level of cleaning of the gas to remove any, like the H2S or CO2 in advance of its use?
Again, on this video, it shows there's a filter here. So you can see that the green filter, the gas flows through that filter, and we use activated carbon, so that will remove the H2S from your system. That's the only filtering that needs to be done.
Okay, I think we had a similar question from James about the integration into the existing gas cooking system, so that we have covered. Question from John, is the MyGug commercially available? And John is asking, do I size it on the cooking gas I want or the food waste available? And then he's asking again the similar question about many others have asked, can I add non-food, so grass or offcuts to it? So
no, you size it based on the food waste that you're generating. So
okay,
you know, and again, like I said earlier, liquid wastes will come into this as well. So if you have yogurt or milks or you know, juices or anything like that, anything with sugar in it, that can all go in as well. So again, I'd like to highlight that generally that's not considered a food waste, but you know, anybody who throws out and gets rid of waste milk or milk that's gone off, they'll pour it down the drain. And that then ends up in a wastewater treatment plant, and a loading, like 1 litre of milk has a biological oxygen demand of about 30,000 milligrams per litre, whereas a litre of sewage has a BOD of 220 milligrams per litre. So it puts a massive strain, and there's a cost on the wastewater treatment plant when liquid wastes go down a drain, whereas in our system, you're harnessing the energy in it and you're using it, and also you're harnessing the nutrients.
Okay, and then the question on the commercially available. So obviously anyone that wants to talk to yourself, you're happy to talk to them about the availability of units. Okay.
Yeah.
Just we have a couple of queries looking for your contact information, Kieran. So is the best way to contact you through your website, mygug.eu? Is that the best way to contact you? So if I think there is an inquiry form through your website, isn't that correct?
There is, a couple
of people. And just to remind our attendees this morning that this webinar will be available on our YouTube channel and available on our website in the coming days. So if you want to look back through, it's available there. Okay, the next question is from John about the electricity supply. So again, can an off-grid electricity supply be used, e.g. a PV system? So
it'd be probably more suitable at the moment for our manual units. So you know, with our manual units, we control temperature, and if the power goes off for a while and it doesn't have power to heat, that doesn't really matter. The temperature might drop a degree or two, and then once you have power again, it'll power up. So yeah, it could be used on an off-grid. Okay,
a similar question to that from Patrick about the volume of electricity that it uses in the winter time. So what is what volume or quantity of electricity is used?
The smaller unit will use about between, I don't know, can you see, that's off screen there?
We can see, yeah.
Yeah, it'll use about between 0.5 and 1.5 kilowatt hours a day. So when the temperatures drop, you're losing some heat. And so yeah, about 1.5, so about the same as a standard fridge.
Okay. Next question is from Margaret. Is the MyGug available to purchase? So I think that's yes.
It is.
So contact yourself, Kieran. Teresa, thanks Teresa again for your question. A super example of homegrown innovation. Are the units available now? So the answer to that would be yes. That contact yourself, Kieran.
Yeah.
How do you access the gas? Can it be plumbed into the kitchen? So obviously, is it by a pipe from the unit to the kitchen?
Yes.
Okay, so you'd obviously place the unit as close as possible to your gas, outside to your gas hob or wherever your gas bottles would be located. Would that be correct? Yeah. Next question is from Keith. How does it connect to the main gas system? So I think we've covered that, Kieran. But
you need to keep it separate from your normal gas, because of safety issues. Down the road, we see ourselves working with maybe gas hob suppliers where you might have two inlets into a gas hob, one from your cylinder and one from your biogas, and or else use a 2-ring biogas hob and a 2-ring gas hob. So there's ways around it.
And can you easily change from one gas? Say you have an extra demand in terms of your gas usage and for your cooking, and can you change easily over from the biogas to your gas container if you need to, or how do you do that from a technical point of view?
Well, at the moment we supply a biogas stove with our units, but ultimately we'd need to work with someone to provide a solution like I was talking about that would provide a seamless solution.
Okay. Question from Siobhan is do you need an outside power source and water source? So I think that would be both. Yes, water for the macerator and power for the heating of the unit.
The units, just to say as well, Sean, that the units have a hose connection, so it's not an actual pipe. It's you can just bring a hose over from a tap and plug it in.
Okay.
Yeah.
Very good. Question from George. Have you worked on any community-based solutions at this for your technology? So that's featuring in a number of the questions, you know, community groups and.
We'd be delighted to. We've had some queries, all right, and we've gone for a couple of grant applications, but we not yet. But we'd love to
just
do
in terms
like
of the community. Then, how would you envisage that working? That it would be the unit would be centrally located, and that people would have the option then of coming to place their food waste in the macerator. Is that the way it would?
Yeah, I'd say so.
Work?
Yeah.
Okay. Yeah. Thanks for that. Ronan, a question: does the liquid fertilizer need any treatment due to all the nutrients it would still contain? If you were to use it in planting, would the planter need to be sealed or that so it wouldn't leach into the groundwater? So maybe if you want to elaborate just on the liquid, and we haven't had many questions on the actual fertilizer, liquid fertilizer digestate coming from it. So do you want to elaborate on that, Kieran?
Well, if you look at the liquid, you're talking about for a domestic unit about 1,000 litres in a year, about 3 litres a day. So you're not talking about huge quantities. So a small garden is enough to use all the fertilizer on.
And while it is in a liquid state, I suppose it's important to point out, maybe Noel, you could come in on this. Digestate, by its nature, is it? Can you just explain its potential from a nutrient point of view and the uptake of that?
Yeah, it's research done in the Department of Agriculture, done by Teagasc, funded by the Department of Agriculture, to look at how digestate operates, and it makes the nutrients far more available to the plant. So it's a very valuable fertilizer material for that reason. But because it's more available to the plant, there's much less potential for, like, say for example, someone using animal slurries. There's much less potential for that to run off into rivers because it's been mineralized and it's in a format that the plants can easily uptake. So in a way, it protects the nutrients for plant use.
Okay. Next question there. Have any of your customers been able to use grants to offset their purchase cost? So
we're working on that. SEI have given us a grant recently to install a digester in a school here in Banton Grammar School, and but we're talking to them to see if we can get grants available for this technology.
For widespread rollout across.
Yes, exactly. Yeah.
Okay. Question here on the bacteria culture. Do you need to add bacteria culture before adding your food waste to seed the unit? I suppose is the.
Yeah, you seed the unit. Once you seed the unit, it should work away. If sometimes if you have too much of one particular type of food waste, you might have to add micronutrients or some bacteria very occasionally, but
to seed the unit, what would you use? Would you just use would you just start adding the food waste and over time the bacteria start to activate?
No, you seed it with a sludge, or there's a company in Dublin we work with also where you can get dried bacteria, and you just mix that with warm water and you start. So you would put it in.
You give technical advice to anyone taking the unit around that.
Believe it or not, a lot of the commercial ones. Earlier on would have used cow slurry as a material. I don't know if you've tried that, Kieran. I presume you have.
Well, the first digester I used, I went across to Carberry Milk, and they have 2 huge digesters over there, and I tell you, it started pretty quick after that.
Okay, so it's a case of trying to locate digesters.
Yeah, well, it's a bit like one digester, the liquid from that can be used in the next digester, and it'll just grow, so you just need a seed, 30-60 litres of seed material, and that's easy for us to provide.
Okay, question from George here. If you install a unit today, what is the timeline to have gas available? So how quickly does it start producing?
That would depend on how much seed material we put into the unit. But if we put 60, 80, 100 litres of seed material, it would start producing gas straight away. And then over time, really it can take two months, 3 months to get up to your full complement of bacteria in the digester, and where you're going to get a full amount of gas.
Okay. More of a comment from Deirdre than a question. Thanks so much to Kieran and Noel. Great presentation. Just to say that she likes the name or loves the name too. So,
thanks, Deirdre.
Next question from Brian. Another one on the economics. How long before the cost of the digester is offset through savings in gas or electricity? So,
well, if we
where
go,
your grant is required to
well,
offset, to reduce
yeah,
that.
I think so. But like, if we go back to this video, like that's where we see the real value in creating this micro circular economy, where you're getting all this produce, you're creating it locally. That's where the real value is. Yes, you're getting gas, but you're reducing your reliance. Now we see straight away since the gas hike yesterday, 39%. Like, who would have thought you'd have a gas hike of 39%? So our real value is you're not relying on anybody else and worrying about other prices.
As a couple into that, like, waste disposal cost as well. Suddenly you're no longer relying on a brown bin that has to be paid for. You've got the obviously the energy value, but also the fertilizer value as well, and you will digestate is extremely good at bringing on different crops. So you will get an increased yield from it.
You're talking now at a larger scale in terms of digestion, but even at
on the smaller scale as well, though, it will have
your garden.
Yeah, for the home grower, you will have a good impact from it.
Okay. So I suppose the main summary point from this question and the answer as well is that there are many benefits beyond the actual energy offset benefits, which probably are hard to quantify, and that is a challenge we face always from a biogas perspective. In terms of the economics, is how to value those non-energy benefits. Okay. Next question from Kevin. What is the delivery time scale on the units?
It'd be about 6 to 8 weeks now.
Okay.
We're working on getting that down, but
yeah. Okay. Have you any resourcing for sizing, pricing, and output benefits on your website or elsewhere? So that's a question from John. So I guess you deal directly with your customers. So if they get in touch with you, you'll be able to provide information. Okay. Congrats, Kieran, and best of luck with your MyGug, a great development. That's from Patrick. So that's a comment.
Thanks, Patrick.
Just to clarify, it would need a separate cooker to use. You wouldn't be able to use or swap a biogas between the biogas and a regular gas bottle and back again, depending on how much biogas you have. So don't ask that question. So just do you want to clarify on that?
Well, look, this is where we need to work with someone like Glenn Dimplex or someone. We ourselves use a standard hob, and it's connected to our biogas, and it's connected to our cylinder gas, but it wouldn't pass any safety standards. But it's really feasible to do. It's really simple, and we just need, like I say, we need 2 separate inlets into a standard hob to be able to use both.
Okay.
And
presumably it would be possible to dedicate one hob for the biogas, and you tend to use that as your primary, and then obviously running low on gas you can use the others. But
well, just to give you, like, for our system here, we've got a gas supply in, and then we've also got a gas supply from our cylinder, and we've got a valve that you can switch between the two. And then on the gas hob, 2 of the gas rings are on normal gas and 3 are on biogas. So you can swap over, but again, it's not ideal. And that's why we supply a biogas stove together with the unit. But ultimately, we see a built-in gas hob with the dedicated biogas rings and dedicated gas rings where you can't mix the 2 up, and that's our goal.
Okay, I suppose a question or a clarification here: do you need a registered gas installer to do this work, do this gas connection work, or is that something?
No,
it's not. But obviously, safety is paramount, so you need.
Yeah. Okay. Look, as I say, with biogas, the bag is at atmospheric pressure, so there's nothing squeezing it to force it into your house. You have to turn on a gas pump, and rather than the gas is compressed to make it transportable. So there's a huge volume and a huge potential energy in a gas cylinder. But with biogas, you're producing small amounts all the time, and you're using small amounts all the time. So it's a completely different system to a gas cylinder.
So there are system items that can
Yeah, like just to give you an example, like with the domestic system, there's upper and lower limits for explosion limits for methane, and the lower explosion limit is 4.4%, and the upper limit is 17%. If you get a mix of methane in air at those percentages and you light a match, it'll explode. To get in those limits with a domestic digester, you need to be in under one of these toilets that's under a stairs with the door closed, and all of the gas from your biogas bag going into that room to give you those, because the volumes are so small. So this is, we're always coming up against this about safety. Oh, it's gas. But we're saying, look, there's 30 million of these in China. They use them all the time. There's no pressure behind it. It's safe. It couldn't be safer.
Okay. Question from Shay. A traditional composter can be used as a worm farm. Does the MyGug hold worms or act as a worm farm in any way? So.
Well, it'll digest some worms and turn them into gas.
But it won't attract them because
no, it won't. No,
you obviously it's not a composter. So composter is a specific.
Yeah, worms. Look, what we've done. I've done a video before of a composter and our digester, and the bacteria are obviously much smaller than insects and worms. So they're lower in the food chain. So anything that comes out of the digester is absolutely no interest to vermin and worms or anything else. So, so
it'll increase the content the nutrient content of your soil though in your garden potentially. So that might be the attraction from the point of view of more fertile soil attractive to worms maybe. Or
exactly, yeah,
Okay, we'll keep going. Is the MyGug supplied stove an additional cost?
No.
So the stove is part of the cost, okay?
Yeah, the unit is supplied with a 1,000-litre biogas bag, a stove, a countertop stove, and the 20-watt gas pump. So it comes with everything you need.
A question here about food waste and can it be reduced in the future? So have you considered that food waste can be reduced in the future? So obviously we all want to try and reduce waste of all kinds. So do you want to address that, Kieran?
Yeah, look, the big goal, and if we look back at the chart that I showed earlier, everybody wants to reduce food waste. It's a huge drain on the resources of the world, and we all want to do that, but we see that micro scale will help people do that themselves. They'll create it, give them less reliance on outside, and so that's our goal. Yes, of course, we want to see a reduction in food waste.
Okay, question from Michael: what's the difference in price between a manual and automated system?
The domestic automated system we aren't retailing, but there will probably be a $2,000 difference in price at least, because again at smaller scale it's hard to reduce price because of the volumes, but ultimately we want to ramp up the number of units that we produce and bring down our price to make it more affordable. But we need to get a larger scale to do that.
Question from Fergal, which is kind of related to this, in terms of consistent feed supply. What happens if you're away on holidays for 2 weeks?
The beauty of anaerobic bacteria is you can leave them idle for months, 6 months, a year, 2 years, and you can when you come back, you can start dosing a bit slower to begin with to get them used to the feed again, but they'll come back up.
And their gas output will obviously reduce as a result of them not being fed daily for that period of time. So there's no risk of your gas bag overfilling or anything like that. Or is there a flare on? There's no flare on the system if that was to happen.
No. It's amazing. Once you stop dosing, the gas pretty much goes up, stops within hours.
Okay. Question from Brian, and we are gone over time, but I think given the interest in this, we've 46 questions answered. I think there's 10 more left, so we'll keep going, Kieran. And for all our attendees, if you could wait on for a couple of minutes, that would be great. We just get through all the questions for the sake of a few minutes. So, question from Brian: how many units are you producing per year, and what are you looking to ramp up to?
Well, we want to sell as many fridges, as many digesters as there are fridges. So, you know, look, we're just starting.
And hopefully you'll have a few more sales after today.
Yeah,
so,
yeah, hopefully.
Robert, question here, and I think Robert says 300 litres a day of biogas from 1.5 kgs of food waste. So I think that's 3 litres, you said, Kieran, just to clarify, wasn't it?
No, it's 300 litres of biogas.
Sorry, apologies. Okay, 300 litres of biogas from 1.5 kgs of food waste.
The big disconnect here is, you know, people are used to gas in cylinders where it's completely compressed. The volume, if you release that gas and fill it into, you know, the atmosphere, it'll take up much bigger area. So,
yes.
Like to give you an example, the bag that I showed in here, the 1,000-litre bag, about 20 or 22 of those will have the same amount of gas as you have in your standard, you know, your yellow gas cylinder. So, so 300 litres is 1/3 of this gas bag. Okay. So you know, when it's at atmospheric pressure, it sounds like an awful lot, but you know that would keep you going for about an hour to an hour and a half of cooking.
Okay. And just Robert says that he assumes that these values have been verified. I think you have the unit yourself, so you can send over your outputs, and these must be based on more starchy inputs, he says. So obviously the quality of the inputs would depend on the volume of output from a gas perspective.
Yeah, look, there's a standard system where it's called volatile solids, and the volatile solids in different foods vary, but I think for food waste, it's generally about 5 kilos will produce about 1,000 litres. 5 kilos of general food waste.
Okay. Question from Liam: is there a demonstrator unit to bring on site, or where can a unit be viewed? And he's a Northern Ireland-based attendee.
And sorry, I missed the name, Sean.
Liam. So
Liam,
is there a demonstrator unit available?
We're hoping to start putting demonstration units around the country to you know, allow people to sort of touch and feel and see how it works. Maybe in 6 months' time, Liam, hopefully.
Okay, I guess Liam, maybe you should get in touch with Kieran through to mygug.eu, and maybe you can have a chat about seeing a unit or something, you know. So John, a question from John about his gas barbecue which he doesn't use over the winter. Any concerns about gas buildup, or could he attach his biogas MyGug unit to his gas barbecue? And then what's the concerns regarding gas buildup and explosion or seasonal storage? So
our system, we have to say, is it's not suitable for seasonal storage because it's
continuous use.
It's continuous. Like if you're using it all the time, to put food waste into, it's going to produce gas all the time. And we look, one thing about gas storage is it's cheap, but you'd need an awful big bag to store 6 months of
and I suppose this all comes back, Noel, to the discussion about intermittent renewable sources and continuous renewable sources. So biogas and anaerobic digestion is a continuous renewable source, meaning that it continuously produces.
Yeah, and like, you know, you have things like PV, which is very reliant on obviously the sun shining, so you won't get much during the winter or obviously at night. You know, and this is your biogas will be able to produce 24/7. Or will produce gas 24/7, so and 365 days a year.
Kevin, a question from Kevin. Again, we've addressed, I think, how much electricity does it use a year. So we've covered that previously. Kieran, just in case Kevin was late.
About the same as a fridge. I keep going back to the fridge analogy, but you know, a fridge is an enclosed container that cools air. Ours is an enclosed container that heats the internals. So it'll use about the same as a fridge.
That's great. Do you measure the gas quality before it is used in the cooker, e.g. H2S, H4, CO2, etc. concentrations? A question from Tom. So no.
We have on on some units, on our larger commercial units, we've got the ability to add methane sensors and monitor the methane percentage in the gas.
Okay.
Yeah.
The footprint of the unit, a question from Kevin. So that's this, I guess that's what square meterage it would cover, or what size?
Yeah, the unit itself is about 2 meters by 1 meter, and then the gas bag is another 1 meter squared. So you can position, you don't have to position them next to each other.
Okay.
You can put the gas bag somewhere else.
A question from Kevin there, is the recording available? So that's a yes, there will be a recording available of the presentation. Cost for a standard domestic unit, question from Kevin as well, he joined late, 3,599 including VAT, and that includes your gas hob and all of the elements of the unit. Back to his worms, so he's saying the poor worms, but look at we, you know,
well, you mentioned there there's organic matter in the digestate, and when you put that organic matter on your
it's
soil,
actually better. It'll get access to more worms than
exactly
the compost unit.
The worms will love the organic matter. So
so you might be helping them in another way.
Oh yeah, absolutely, yeah.
And the final question. If you're away for a period, do you run the risk of the unit running out of food, or does the balance tank hold enough to keep the unit running for a few days, weeks? So I think we've covered that from the point of view of that the gas output is minimal when it's not being fed, and the bacteria, it doesn't impact. You want to clarify?
Well, it just on the automated unit and the balance tank has enough storage for about 3-4 days of food waste. So like if with the manual, if you don't dose every day, the gas production will stop. But with an automated unit, it'll empty the balance tank until it's empty.
Okay, just a couple of other points in the chat. So Ben, he would like to look at incorporating this digester in one of his own projects. So we've addressed the questions. So I guess, Benny, if you want to get in touch with Kieran, it would be the best way to progress your proposal in terms of a collaboration. And the presentation or the video will be available on our website after. We've covered how much are they. We've covered about the cleaning. It doesn't take grass cuttings, where Kieran, you're very clear on that is food waste only. And then just Shay comments about the circular approach. So we've covered that. Warranty is a question that hasn't been covered. What is the product warranty?
For the mechanical parts, we give a year warranty, but on tankage and the other parts, we give a 5-year warranty.
Okay. Can you put in animal manure? We've answered that. Does the system need a consistent feed daily? It does. I think we've answered that. What happens if you're away on holidays for 2 weeks? We've covered that already. Okay, and just Brian, we have a lot of complimentary comments from a lot of our attendees this morning. To you, Kieran, for your innovation and your foresight in terms of the technology. So I'd like to compliment you on that. So we've had over nearly 70 questions between the chat and the Q&A, and I think we've answered nearly all of them. So I thank everyone, all our attendees this morning, for asking and attending and asking all the questions. I thank you, Kieran, for your attendance as well, for taking time off your busy schedule to present. But also I want to wish you every good wish with your technology, and I hope it becomes a mainstream across Ireland and indeed Europe over the next number of years. So
thank you, Sean.
And also thanks very much to Noel for helping and assisting with the questions. I'd like to also acknowledge Teresa O'Brien, who's our colleague behind the scenes, who makes all this work. And thanks, Teresa, for your time and efforts in getting this. Was webinar number 30, so we've reached a milestone in terms of 30 webinars, and we hope to continue on a fortnightly basis because we are getting very good attendances and a lot of interest. So with that, I think we conclude. Apologies, we've gone slightly over on our time this morning, but I think the interest in the topic or the area and the technology kind of justified the extra time. So we'll leave it at that, Kieran, and I thank all our attendees, and I hope you have a nice weekend, and we look forward to seeing you on the next occasion. So thank you. Bye-bye.
Bye-bye.